Yeah, so cyber agricultural system is an overarching framework that brings the concept of cyber physical systems into agriculture. So it basically gets together with ubiquitous sensing, AI, and the smart actuation, and a really efficient cyber infrastructure, all coming together to make production, ag production, and breeding more efficient, more profitable, more sustainable. So that's the whole idea about cyber agricultural systems, and essentially it integrates digital ag, smart ag, and precision ag into this overarching framework. Yeah, so CIS has really three technical pillars. So one is sensing, and then modeling, and then actuation. So sensing basically means that we put out a variety of sensors in the field, we collect a lot of data, and that goes to the modeling phase where we build computational model ingesting all this data to make sense of it. And then the third part is actuation, where once we understand, when we are able to reason about what's going on, we can take that actions back to the field and make changes so that these things get better.
Cyber agricultural system, or CAS, is another way of calling it. It's a high-tech way of farming or breeding depending on the context, and essentially what we are doing is we are combining the physical world of agriculture or breeding, depending, as I said, on the application, along with some advanced digital technologies and computation. You can think of cyber agricultural system in the context of doing it a smart way of farming, smart way of breeding. Think of smart homes, think of smart cities. They have all these types of sensors that can be utilized to give information for us to do things better. And that's how I approach cyber agricultural system. In the context of farm, let's think about cyber agricultural system in the context of farm. We have sensors that can be placed all over the farm. We can collect data on soil moisture, we can collect data on crop health, we can collect data on weather conditions. We have this data that can be coming from strategic places on the farm in a real time. How do we take all of that data to go into a data processing in which we utilize these powerful computers? This computation gives us insights because we use artificial intelligence, we use advanced computational algorithms, and that information is fed into what is called decision support tools. Think of smartphone apps, think of iPads, think of any technology where we have the information in front of us, but ultimately it comes back to the human. Whether it's a farmer or it's a breeder, you have to take decisions to implement those decisions. This can be done through smart machinery, it can be machinery on the farm, it could be some other way of making those decisions or implementing those decisions. So it is critical that we have all the information that we need to utilize that high technology that is coming our way. And that, in essence, is what I see smart cyber agricultural system. You can also think of how do we place fertilizer? When do we water? How much do we water? Where do we put pesticides? How much pesticides should we put? All of this comes in the context of cyber agricultural system. So in a nutshell, if I have to wrap it up in a few words, I would say that it's a smart way of doing farming or breeding, developing new crops for the climate smart agriculture to make sure that not only are our new varieties highly productive, but they're also sustainable and helpful for the environment.
The goal of all this technology is to make farming more efficient, sustainable and productive. So instead of treating an entire field the same way, each plant can potentially receive individual care. This can lead to less water waste, reduce use of chemicals like pesticides, herbicides, fungicides, and this can also result in early detection of plant diseases and pest problems, resulting in better crop yields and more environmentally friendly farming practices. So it is like having a team of experts watching every single plant 24/7, but using technology to do it, because at that scale it is not possible for humans to do it alone.
Right. So if you think about traditional farming, at least in the US right now, it is typically large scale using heavy machineries and does field level chemical application, widespread chemical application. So that is one of the things that cyber agricultural systems is going to change, is from widespread application. We are trying to get ultra precision applications of inputs through lightweight, multiple, smaller equipment rather than heavy machineries.
So CAS has numerous benefits. You can think of those benefits in the in terms of efficiency gain, you can think of in terms of increased sustainability, increased productivity, think of resilience against changing and variable climate, and also in terms of improved profitability. Because of the ultra-precise nature of cyber agricultural system, what happens is that you only need to apply inputs, whether they're fertilizers or any other kind of pesticides or any other kind of input. You only have to apply it when it is needed and where it is needed. What that means is that we have reduced environmental impact, we have better resource usage, and we minimize the damage that comes out of excessive and indiscriminate use of these chemicals. And we are also optimizing the overall farming system. So you can see that there are lots of different applications, and as this field grows, we'll continue to see more and more benefits that will come out of this.
So in plant breeding, cyber agriculture systems can help in high throughput phenotyping and automating various processes, especially for taking plant traits, and this can help in measuring these plant traits rapidly and non-invasively, and that can help in making a lot of crop breeding decisions.
Significant challenges to implementing CAS, along with a lot of opportunity and value add. Some of the challenges include: how do you store all the data? How do you deploy complicated, multifaceted sensing and actuation equipment out in the field? Another set is, if you want to control such equipment across hundreds of acres, you need to have good connectivity, especially broadband in rural areas. Finally, there are questions about data privacy and reliability, which essentially go into acceptance of such technologies.
Yeah, I think the future of cyber agricultural system is really exciting. I'm going to give you a few examples. So cyber agricultural systems are giving rise to this, what we call agricultural digital twins, that are helping us to simulate virtually what's going on in the real field to make a lot of critical decisions. And it's going to get better to take on more complex agricultural challenges. Secondly, it's giving rise to autonomous robots, drones, that will be able to do a lot of complex tasks in the field, and also the cyber agricultural systems are supported by the advances in AI and machine learning, computer vision, and these fields are progressing fast. So we're going to see a lot of these advancements from computer science, engineering come to crop production, crop breeding. So it's really exciting times.